Okay, we come to our last session, last but not least. Frank.
Thank you. Oops. Hello, I'm Frank. Some of you may know me already. I also work in security at SAP. This is a presentation that's not only about security, and because it's something I'm quite passionate about, because we see it being a problem for security, but it has other aspects as well. So in our job, we look at the security of SAP products, and we have literally checked thousands of products for security issues. And one thing we see coming up a lot is open space and open source. But talking about the issue from a security angle only is not helpful, so I tried a different approach this time. Let's start with some audience participation time. So, who of you uses open source in code? Yeah, keep your hands open. When have you updated components for your latest build? Okay, some hands go down. We'll see the effect of that later on. So why would you care about open source? This is how it started. When we developed software, we used a small piece of open source code that works. And somehow this is now turned around, that open source is mainly the majority of the code that runs in products that are being developed nowadays. Sometimes it's up to 80 or 90%. If you look at stuff like machine learning or IoT or anything with Docker, it's more than 90% of your code. So it's quite an important thing to look at. The term lifecycle is not necessarily the first thing that comes into mind when you think about open source code. So how does development work, or how do lots of developers treat open source? You work on your code. You do some kind of tests. You hopefully have automated tests if you're really good. You have functional tests. You may check for security issues. You do penetration testing. And for the open source part of things, if it works, it's fine. I don't think many people look into the actual code, even though it's open source. Yeah. In your next release, time passes. You're doing all these checks again for your own code. And for the open source, it still works. And so in products, when we look at open source components, we find stuff that is quite old somehow. I think the oldest code we found is from 2005. And that is less uncommon than I would like it to be. Yeah. So, and remember, we had the 80% is the open source code, and 20% is your code. So let's look at a small example. This is an SAP Cloud Platform demo application that Matthias Steiner wrote some years ago, and that I forked from his GitHub account. And as it happens, this code is just lying around somewhere. And the idea is that it's probably going to be perfect, because 1,000 eyes have looked at it. So it has to be good, because magically, by the time that you decide to include this open source code, it's in an absolutely perfect state. It does not have bugs, it does not have security vulnerabilities, because you picked it. The reality is that you now have quite a few developers in your team that you didn't know about. And I'm not sure how good you are as a hiring manager, hiring developers for your team, but all these people have committed code to these handful of open source projects, which is a very small list of open source modules. We have, the larger open source components have up to 75,000 developers working on them. So these are all people that write code that ends up in your product. So what do they do, the people that write 80% of your code? Yeah, so what did they do in 2018? They did 4,022 commits, 4,122 commits for these handful of projects. They added 422,000 lines of code. And they fixed 5,345 issues. And we're not talking about security here. These are all things that may influence the life and death of your product, yeah, because they have stuff like web standards change, protocol standards evolve, browser behavior changes. And when we're talking about cloud applications, all of these are somehow relevant, I'm pretty sure, for your product, but it doesn't seem to be coming to the mind of people to look at the open source part of your code. Yeah. So for example, Spring Boot is something that's used by quite a lot of people. They fixed bugs in 2019. They fixed 391 bugs. In 4 weeks of commits, they closed 302 issues. Let's discard a few that are opened by mistake, but they still fixed 302 issues. Some of them may be relevant. So in short, this code is actually being worked on. Yeah, it's 80% of your product, and these developers are working on it. So why disregard all this work? What about security? Well, you can make it simple. This is something that you can pin on your wall because it's never going to be false. Yeah. Or you can be a little bit less positive. But in the end, these open source things are code just like anybody else, and the good message for you is open source developers are probably not better at you than securing your code. Yeah. You've all heard of these, you heard of Heartbeat, you heard of Spectre, and these are all the big ones that get all the news, but there's lots of small ones too. There's things like typo squatting, like people, was it too fast for you, Henrik? People creating packages in NPM, for example, with slightly mistyped names that you then include in your product, and which then starts mining bitcoins in your cloud instance. But we have all this feeling that the developers will surely fix it, right? Because it's open source, so people who put it fix it. But there's things like the one in the middle where somebody said, well, can I be a maintainer for your code? And the guy said, sure. He gave him maintenance rights and he kicked him out. And suddenly it became malware. Yeah, or you may remember the one time that somebody pulled an NPM module, which was called write pad, which just padded a string with lengths. The guy pulled it from NPM, and all kinds of large software packages started breaking around the world. Yeah. The guy in Ukraine is my favorite one. Yeah, so all these open source maintainers may not be as eager on fixing your bugs when you might want them to. Also, in all of these open source packages, you usually pull them in to do some specific thing or two, or even use parts of a framework. But there's code in there that you're not using, but somebody else may. If you're deploying stuff on the web, it may have an admin UI that you didn't even know about, that may now be exposed to the internet. The famous example is by MongoDB, which by default had opened all their connections to the internet. Yeah, so what the developer thinks of how security should be treated for their module may not be what you need in your product. Yeah, so even if they develop secure code, however you may define that, the settings or the way it's run may not be secure in your context. Also, there's open source in your open source. Yeah, so all of the larger projects contain many internal other open source projects. So a larger module may include some other tools that they use, and they may not be quite up to date. So these are the top 20 Java libraries from 2018. Jackson is an XML parser that lots of people are using. just as an example. And the question, of course, is Jackson dangerous? Sometimes it is, yeah, because this is actually, XML parsing seems to be a tough thing to do, because this is one of the modules that creeps up every week or so with a new vulnerability. So it's heavily vulnerable. I'm pretty sure that somebody in this room is right now running an insecure version of it. And it's quite easy to find you if you do that. Yeah, because there are tools on the internet that look for open source, the visibility of open source in products that are on the cloud. Yeah, so there are tools that can scan your URLs and identify open source packages used. And there's even a database that tells you how to exploit it. And so all of this can be done, will be done, and is being done right now. So it's a good idea to actually look at the security of your open source products. So what can you do? Where's the good news? First of all, know what you're using. Yeah? Don't pull in stuff just because you think it might be working for you. Try to find a package that is a bit grown up and has actual developers who are maintaining it. And if you're really good, test what you're using, which means test the APIs that you're using from open source packages. And the reason for that is that you can upgrade without having doubts about the functionality, which is probably the most important thing you need to do. If you look at modern software like mobile operating systems or the Google Chrome browser, the first functionality that they implement is automatic updates. And that needs to be the default for any software we will be writing from now on. Because if you can't update, you're giving away control over your software. There's a tool that helps you keep oversight over what kind of open source is in your product. It's called Dependency Track. It can easily be started. It's available as a Docker image as well. And it takes input from your Jenkins pipelines, for example, and creates a list of all, a database of all the open source software. It tells you the version you're using. It tells you the current version as well. It tells you about vulnerabilities, so what's wrong with it. So that's quite a handy tool. It's open source as well, free to use, so that's a really good idea. Next steps, find out if there's something wrong with your software. The open source code, again, the 80% of your product, will have vulnerabilities just because it's software written by humans. And people will find it, and people will even look for vulnerabilities in outdated or old versions. Yeah, so there's lots of people trying to find those, and there's new ones coming up every day. Yeah, so even if you successfully checked, you then deployed your software to the cloud, the customer has been using it for a year, there may now be a vulnerability or two in this software you're running, because you need to check again and again and again, and if it has to be, you need to update. That also can be done easily, freely with open source. There's a thing called Dependency Check, which is a plugin for your pipeline, which will look at the open source that you're using in the product, and then tell you about all the vulnerabilities and put them up to dependency tracks, so you can have a day-to-day oversight of where you are in terms of known vulnerabilities. It's really easy to include. Yeah, so it's just has a couple of actions for Jenkins and will provide you with the details. It's also good to do that just to find out if there's something new. Yeah, because if you don't know, I mean, if you have like 100 open source modules in your code, you do not want to go to all of these sites manually and find out if something has happened to it. Some new version has been coming up. If you're on GitHub, it's even easier. Yeah, GitHub is heavily pushing the idea of making code continuously more secure. And one of the things they do is they have automated security updates now, which means you can switch that on the security tab of your GitHub repository. You activate automated security updates, and every time one of your dependency changes or has a known security vulnerability, they will send you a pull request. And all you need to do is click on accept and merge the pull request, and you will be current. If if you want to have fun, clone some of the public open source projects you're interested in, activate this flag and watch. And step 3, fix the dang bugs. Yeah, I mean, if somebody tells you about a bug in your code, you'll be up and running and fixing it in no time for your customers. And the same needs to be true for anything you find in open source. And it's also completely fair to push things that you find back to the open source community. Because open source is meant to be community supported. But my guess would be like 90% of open source users are just pulling stuff and using and never contributing. So that's also a call to contribute. And there will be bugs all the time. Functional, security, performance, standards, whatever, which is totally normal. And your best, I mean, we have internal discussions whenever we find something with vulnerabilities all the time, and people will say, yeah, that code is not reachable, or that bug is really not that serious, it doesn't affect my code. And yes, you can do that. You can argue that if you have like 2 open source modules in your code, but that's not a sustainable strategy. And if next week there's a bug that comes up that is severe and that does affect your code, and you need to update within a day, and you can't do it because you haven't done it for 5 years, you're going to be in trouble. So the #1 capability for developers in a DevOps cloud world is being able to update on command all the time. And that's a quality of a software that is above everything else. SAP also does this. We have an internal team called the Phosphor team that actively goes out and patches bugs in open source. We have, for now, started to work on Spring Boot. And there's some other components where SAP employees look for security issues and fix them. Or they update the dependencies of Spring Boot, for example, and provide a more secure version and pull it back to the team. So that's something we do all the time. Yeah, to summarize, that's whole thing is kind of an attempt to create an open source development guideline, like how should you be working with open source for security reasons amongst others, but mainly driven by the idea that if you have if you get into the habit of updating your open source regularly, not necessarily every day, but maybe every build, or every minor or major build, you are used to doing it, or you have the capability to do it if you need to. Yeah, and nobody will surprise you with a sudden urge to update. It will just be normal. And that's where we need to get to. We get all this software for free. The least we can do is use the current version. And that's about it. Thank you.
Any question?
Yes.
This sounds very much somehow open source is unsecure. I mean, of course, you have named reasons, but aren't these reasons true for commercially purchased software as well? Where I even might not be able to look into a library I have purchased from some software vendor. I mean, it must be buggy too. Of course, I should have a regular update. Aren't the same things you told us true for them as well?
Which is why you should be asking your commercial software vendor if he does that. Yeah. So we look at partner software as well. So partners that are certified SAP partners and want to sell software on the SAP price list, we check their software too. Yeah. we make them update stuff, and we ask them to be to care for secure development, which is new for some of them, which it is for many developers. But that's something that really needs constant reminders. Yeah, we all know how difficult it is to care about all these different things that are all kinds of new technologies come out every week that we're supposed to be using. But this needs to be a habit. And once you have made it a habit, it gets a lot easier. It's only a problem if you need to do it by surprise.
Yeah.
I can underline this by a personal experience that I had. I used to, or still use WordPress, open source, and didn't update it for years.
It's not on Windows now, is it?
It was hacked, and it was hacked in a way that if I call my site with the URL, I get a clean URL. If you search my page and comes from Google, program will be installed on your computer. So a customer of mine said, "Oh, how can I reach you?" or what? And I said, "Google me," and then click. And I heard, I said, "What happens with my screen?" "Oh, I have to call you back because my computer is affected." That was I didn't lost it, but it was nearly. And so now I have switched on in WordPress, update your regularly by yourself. They have this now, and so I can organize this. Okay, thank you very much. It was worth to free you from the escalator.